Hello geniuses, Ms. Sorensen here. We're going to try to breeze through this review packet for the unit Advanced Trigonometry. Let's get started. So we're going to prove that the double angle formula works for sine of 2 times 45 degrees. And if you look at our formula right here, our theta in this situation is 45. So really what we have here is to apply the formula to sine of 45 and then cosine of 45. All right, well, I'm going to work with the left side of the equation first, and I know that the sine of 2 times 45 is the sine of 90. And if I look at my unit circle here, I go to 90 degrees, and I know my sine is the second coordinate, so this is going to be equal to 1. I'm just going to bring down my equal sign. Okay, now I really have to start evaluating the right side of the equation. So I'm going to rewrite the 2. Sine of 45 is located right here. Right here's 45 degrees, so that's going to be root 2 over 2. And cosine of 45 is also root 2 over 2. Okay? All right, we know that these 2's cancel right here, so we're left with square root of 2 times the square root of 2, which is the square root of 4, all divided by just plain old 2. Well, what is the square root of 4? It's 2. So we're left with 2 over 2, and that's going to be 1 equals 1. And so since we have both sides of the equation equal, that means that we know that the answer is correct. All right, let's take a look at the next one here. We've got sine of 2 times 5 pi over 6. I'm going to write this over here for a little bit more room. And what is 2 times 5 pi over 6? Well, always multiply the numerators and then the denominators. So this is going to give me sine of 10 pi over 6. And reducing that, that's going to give me sine of 5 pi over 3. And then I'm just going to go ahead and I'm going to look at my unit circle, find my 5 pi over 3. Sine is going to be the second coordinate, is a negative root 3 over 2. And now I can work on my right side of the equation, which is going to be applying this formula right here. So I'll have 2 sine of 5 pi over 6 times cosine of 5 pi over 6. Rewrite the 2. Sine of 5 pi over 6, let's see if I can find that on here. Okay, here's my 5 pi over 6. So my sine is going to be 1/2. And then my cosine is going to be negative root 3 over 2. Of course, my 2's cancel because one's in the numerator, one's in the denominator, and I'm left with negative root 3 over 2, which I can rewrite as negative 3 root 2 over 2. Same thing. So since we have that same thing, we have the correct answer. All right, let's take a look at the next problem. The key on these is to make sure you're in the right quadrant and you've drawn your triangle correctly. So I'm going to draw this, and I'm noticing that we are in between 3 pi over 2 and 2 pi. Well, that's going to be 3 pi over 2 is here, and 2 pi is here. So to draw this, I have to realize that cosine theta is adjacent over hypotenuse. So I'm going to draw my triangle, which you should know looks like this, with my theta right here. And my adjacent is going to be this side right here, and my hypotenuse is going to be this side right here. And so that's going to give me 9 here because of the A here, and then I've got my hypotenuse being 15. So then you have to do Pythagorean theorem, which you're welcome to do. I'll do it real quick. That's 9 squared plus x squared equals 15 squared. That's 81 plus x squared equals 225. Subtract 81 from both sides, and 81's cancel. I get x squared equals 144. Square root both sides, and I get x equals 12. So I know that this is a 12 right here, but it's also going down, right? This is going right, which is positive. So because the 12 is down, there should be a negative here. All right, next thing that we really need to do is come up with the sine theta and the cosine theta, but it actually looks like in this problem they already gave us cosine theta, which is kind of nice. It's like half the work is done for us there. So I'm just going to rewrite that. So we've got cosine theta is equal to 9 over 5. Now I need sine theta, which is opposite over hypotenuse. Well, my opposite is negative 12 over my hypotenuse of 15. Okay, now I'm just going to go ahead and plug right into my formula. So it's going to be sine 2 theta, which is what they're asking for right here, is equal to 2 sine theta cosine theta. Okay, so sine 2 theta is going to be 2 times my sine theta, which is negative 12 over 15, and then my cosine theta, which is 9 over 5. And then I like to rewrite this with a 1 and multiply across my numerators, and I get negative 216. Multiply across my denominators, and I get 225. Putting that in my calculator and reducing it using math fraction, I get negative 24 over 25. Okay, number 4 here. If secant of theta is negative 13 over 5, and it looks like we are in the second quadrant, find sine 2 theta. So like I said, we're in the second quadrant. Why did I know that? Well, we're from pi over 2 to pi, and pi over 2 is right here, and pi is right here. So I know my triangle looks like this. My theta is here. All right, and so we've got here secant. Well, secant is the reciprocal of cosine, and cosine is adjacent over hypotenuse. So this is going to be hypotenuse over adjacent. So let's not deal with the negative yet. There's a little bit of a trick there. I tried to trick you, sorry. But we know that the hypotenuse is 13, and we know the adjacent is 5. And so one of these should be negative, and the hypotenuse is never negative in this situation, but we are going left 5, and so that 5 is going to be negative. And then you're welcome to do Pythagorean theorem, but you should know this one by heart, the 5, 12, 13 triangle. So we're going to put a 12 here. All right, let's calculate sine theta. Sine is going to be equal to opposite over hypotenuse. My opposite in this case, sorry about that. The opposite in this case is 12, and the hypotenuse is 13. Okay, and then the next thing we have to get is cosine theta, which is the reciprocal of secant, so you can just swap the two things above if you want, or let's just double check that we have our picture right. So cosine theta is adjacent over hypotenuse. In this case, that's going to be negative 5 over 13. And looking at this here, that makes total sense because cosine and secant are reciprocals. All right, so sine 2 theta is going to be equal to 2 sine theta cosine theta. So this is going to be equal to 2 times 12 over 13. And then my cosine was negative 5 over 13. I like to put this over 1. And I get an answer of negative 120 over 169. Sweet. Next thing that I'm going to do is I'm going to take my answer to number 3 and prove that my answer was correct. So if you go back to number 3, I got negative 24 over 25. And so my answer I should write as negative 24 over 25, but I'm going to convert that to a decimal, and I get a negative 0.96. All right. First thing I like to do is check that the sign is correct. And so to do that, I'm estimating what sine of 2 theta is. So remember, we were located on this particular problem in the third quadrant right here. Okay, so we were here. And so we're estimating what this angle is right here. Kind of off on that, sorry. We're estimating what that angle is right there. And I'm going to say that that theta is roughly 300 degrees because it's more than 270, which is the 3 quadrants. Which means that my 2 theta, because I'm looking for sine 2 theta, is going to be roughly 600 degrees. Well, we know 600 degrees can be split up between a 360 and a 240. Okay, so let's see if I get a different color here. Look at me. So our 600 degrees is going to be a full circle, but then a 240, which is going to be a 90, another 90, and it doesn't quite get to 270, right? Because 240 is less than that. So our 2 theta ends up being in the third quadrant. And remember, all students take calculus, so the only thing that should be positive in the third quadrant is tangent, meaning our sine should be negative. Well, was our answer negative? Yes, it was. So we've checked that, and so we're good to go on the fact that we got a negative answer. All right, next thing that we're going to do is we're going to actually get the correct angle. And so to do that, there's a couple ways you can do it, but I like to I remember that my triangle was a 9, negative 12, and a 15. And I'm going to take the cosine inverse of what I was given right here. So cosine inverse of 9 over 15, that's going to give me 53.13 degrees. And if you look at our original angle, what we have here is starting here and going to here. I want to know what that angle is right there. Well, that's actually my 53 degrees is right here. So to get what my orange angle is, I'm going to actually do 360 minus that. And I get that my theta is equal to 306.869 degrees. And I was really close at guessing that correctly, so go me. All right, so if my theta is equal to 306.869, I just double that to get my 2 theta, which is going to be 613 let me go crazy here, 73979. And so then I just have to check what sine of 2 theta is. So I'm going to check what sine of 613.73979 is, and I get negative 0.96. And that makes me pretty excited because that is actually what I got in my problem before. All right, good call here. Let's take a look at number 6. Take your answer to problem number 4 and prove that your answer was correct. Well, for number 4, this was my answer. And just a reminder, this is what my triangle looked like right here. So I'm going to write that my answer is negative 120 over 169, which is equal to a negative 0.71. And just a reminder, my triangle was right here, and it was a 12, negative 5, and a 13. So we're going to go ahead and we're going to guess what theta is. So my theta, just as a reminder, I know I'm kind of using this twice, the word theta, but in this case, I'm talking about my angle being this one right here. And I'm going to guess that that is, I don't know, it's clearly more than 90, so let's just go with about 100. And technically, I shouldn't put an equal sign here because I'm guessing. I should say like this, but not a big deal. So 2 theta here is going to be roughly 200 degrees. So 200 degrees is going to be more than 180. It's going to end up being in this quadrant right here. So again, I'm in the third quadrant, and I know sine is going to be negative because all students take calculus. Just like my explanation above is the same here. So did I get a negative answer? Yes, I did. So I know that I should have a negative, and so that's good. I've checked that sine is negative. All right, next thing that I'm going to do here, though, is actually find what the angle is. And to do that, I'm going to do sine inverse. And I'm going to get rid of the negative here because we really just care about the angle. We don't care about the direction of the triangle. So I'm just going to have 12 over 13 for sine. And if you're confused how I got that, I looked here at this problem right here. That's going to be opposite, and that's going to be hypotenuse. So there they stay positive. But you could have done cosine inverse of 5 over 13, which is the reciprocal of this, but we're keeping it positive. It doesn't matter. Just create a triangle with positive values in there. That's true, right? Sine inverse is opposite over hypotenuse. So once I do that, I actually get a theta, and I find out that my theta is equal to 67.38. So to find out what this orange angle actually is, I'm going to do 180 minus that, because you can see that that orange angle right there is just a little bit less than that 180, and we just found what that angle inside the triangle is. We found that this right here is 67. Okay, so 180 minus that gives me that theta is equal to 112.6198, which means my 2 theta, I'm going to double that, and I get roughly 225.24. So I was a little bit off on my guess, but that's all right. So then I find sine of 2 theta, which is sine of 225.24, and I get an answer of negative 0.71. There we are. All right, here we go. Let's prove that the half angle formula works. So again, I'm going to work straight down here. I'm going to say cosine of 120 over 2, and that's going to give me cosine of 60. And I go back to my unit circle here. 60 is right here, and my cosine is 1/2. Okay, so I'm just going to write that as 1/2. Okay, now I need to apply the formula, which is plus or minus the square root of 1 plus cosine theta over 2. Well, we actually have to think about, is our answer going to be positive or negative? Well, if I'm at cosine of 60, I'm in the first quadrant, right? So the first quadrant is right here, and all students take calculus, meaning all are positive in the first quadrant. So I'm going to actively choose the positive for my square root here. So I'm going to choose the positive. So I'm going to have the square root of 1 plus cosine theta over 2. All right, now I have to find what cosine theta is. In this case, what is my theta? Well, look at the formula. It's the numerator here. Okay, so my numerator in this case is 120 right here. So I'm actually looking for cosine of 120. So I'm going to rewrite that here, and cosine of 120 is located right here. It's negative 1/2. So I get 1 plus negative 1/2 all over 2. And we all know that 1 minus 1/2 for my numerator, 1 minus 1/2 is clearly 1/2. So I've got 1/2 divided by 2. Okay, well, let's think about what 1/2 divided by 2 is. Well, 1/2 divided by 2 is the same thing as 1/2 times 1/2, which is 1/4. And when I take the square root of 1/4, I can rewrite that as the square root of 1 over the square root of 4. And well, square root of 1 is 1, and the square root of 4 is 2. So I've just done this work off on the side, so I can say 1/2 equals, well, I know it reduces to 1/2. There we are. All right, number 8. If tangent of theta is equal to negative 24 over 10, looks like we are in the second quadrant. Find cosine of theta over 2. All right, so we draw our quadrant. We again confirm we're at pi over 2 to pi. Drawing my triangle. I've got tangent of theta, which is opposite over adjacent, so that's going to be 24 over 10. And I really encourage you to kind of leave the negative till you realize what's left, right, up, and down, because I can put that negative anywhere I want here. And I kind of am trying to trick you a little bit about it saying, hey, it has to be with the 24, when in fact it's actually where? It's actually with the 10, because the 10 is going left. So I'm going to put that negative 10 there. And then if you do Pythagorean theorem, you find that your hypotenuse is 26, or you can realize that this is actually, I think it's a 5, 12, 13 triangle doubled, right? So if you had a 5, 12, 13, and you times everything by 2, you get that triangle above. All right, so anyway, now that we have our triangle, we have to go ahead and figure out where we're at in terms of theta over 2. Should we choose the plus or should we choose the minus? And we actually kind of do our check step first here for this particular problem. What I mean by that is we're going to guess that my theta is approximately, I don't know, 100 degrees, let's say, because it's more than 90. Again, what I'm talking about for my angle is this one right here. So that's roughly 100 degrees. So what would theta over 2 be? Well, that's cutting theta in half, and I get 50 degrees. So where is 50 degrees located? It's located in the first quadrant. So if theta over 2 is in the first quadrant, we know that cosine is positive in the first quadrant. So we're going to choose the positive answer here. Let's go ahead and plug in now. We've got cosine of theta over 2 is equal to the positive of 1 plus cosine theta over 2. So this is a good reminder that I actually have to find cosine theta. So I'm going to go back to my triangle here. Cosine theta is going to be adjacent over hypotenuse, which is going to be negative 10 over 26. And you're welcome to reduce that, but I usually don't. So what we have here is, instead of cosine theta, I'm going to write this as negative 10 over 26. And then I'm going to pull that off on the side, and I'm actually going to do the combining of the numerators. So if I want to combine 1 plus negative 10 over 26, I have to write 1 as 26 over 26, and that's going to be minus 10 over 26. So that's going to give me 16 over 26, and that reduces to 8 over 13. So this is going to give me the square root of 8 over 13 divided by 2. Well, what is 8 over 13 divided by 2? That's going to be 8 over 13 times a half, and that's going to give me 8 over 26. And 8 over 26 can be divided by 2 for both numerator and denominator, and that gives me 4 over 13. So this gives me the square root of 4 over 13. And that's going to be equal to, well, the square root of 4 is just 2, and then the square root of 13 is root 13. And then I need to go ahead and rationalize my denominator. So I do that, and I get 2 root 13 over 13. And that's my answer. Sweet. All right, I'm going to pause this video, and we're going to have a part 2. So thanks for watching.